5. So in today's video, I'm going to give a brief introduction to doing linear regression using the built-in features from sklearn or scikit-learn. So I'm not going to go too much into the theory. I'm just going to go more in kind of the implementation of this. And then we'll talk about some different methods in future videos. But for the first series of videos this week, we're going to focus just on kind of linear regression. So the first thing I'm going to do is actually create some fake data. So let's just do MP linspace 0 to 10, and maybe we'll do 20 points. And then maybe y, our data set, will be 2 times x plus 1. And then maybe we'll add a little bit of random noise. And this will also be size of 20. So we can plot this up. So plt plot x comma y. And we're going to do just line width 3. Let's do color of red, and then do plt show. Oop, and linspace. All right, so we have a data set here. It's fairly linear. If we want to make it a little bit less linear, we can actually increase the noise. So here I'm just using random numbers. So we kind of have a spread here in our data set. And what we want to do is fit basically a function to this. We want to fit y equals ax plus b. So we're going to do kind of the model y is equal to ax plus b, where again, this is the slope of the line, and then this is the intercept. And so this is actually fairly easy to do in Python using sklearn. So what we're going to start off with is what we're going to do is we're just going to define a model. So we're going to do model is linear model, and then from that there's lots of different linear models. I'll talk about some later, but we're going to do linear regression and regression. And so I have my model defined, and then once I have my model, what I want to do is kind of fit it to the data. So the way it works is basically what we're going to do is that this x vector, so right now if I just look at the x vector, we have an array that's kind of just a standard NumPy array. But what linear regression is going to do, or is going to require, is that we convert this to a column vector. So we can just do this simply using the trick. We're going to say x data is equal to x colon MP kind of new axis, which is telling us to create a new axis. And then we can just print this out. So we can print x data. And what this is going to do is convert our data into a column vector. So now we actually have a matrix where we have a single column. Why it requires this, don't ask me, but a lot of this is because once we start dealing with multiple linear regression, so rather than just one x, but we have multiple features that we want to try to fit, the columns are going to be important because each one of these represents a different sample. And then if we have columns going on, there's going to be more and more features in our data set that we're going to try to fit. So once we have this together, we can just do model, and we can do fit, and we're going to do xdata.y. And basically it's just going to give us true. And that's going to be our fit of our model to our data. And what we can do is we can also look at the coefficient. So I can print here, I can do model.coefficient. And what this is going to be is the first one. So this is our slope. Let me clear this up. So slope, and then we can do percentage G and percentage there. So that's going to be the slope of our model, right? It's an array because right now we have one variable, but we can also have potentially multiple variables. And then we can also print out what the intercept is. So this is the intercept percentage G. Put a colon, and then we can look at basic model dot intercept with an underscore, and that's going to give us our intercept. And you're going to see the numbers. We get 2 and 1, which is fairly close to the model that we did. So the next thing we might want to do is print up the model or take a look at the model. So what we can do is we can expand the range. So right now our data is between 0 and 10 with only 20 points, but maybe we want to do x predict, and maybe we want to do MP linspace between 0 and 10, and maybe we want 1,000 points. And now, as before, I want to convert this to a column vector, so I'm going to be tilde MP new axis. And then I can say yPredict is equal to model.predict xPredict. And what that's going to do, whoop, I keep on linspace, and now we have our prediction. And then I can do PLT plot, I could do xPredict, yPredict, and maybe I'll do line width of 3, I'll do color is equal to blue. And then I can do PLT plot. Actually, let me just grab it up here. And where I'm just going to plot out the individual data points in red. And as you see here, we have our line being fitted through our data points, right? And so here are kind of our data, and here's kind of the best least square fit using linear regression to our data set. The last thing we might want to do is we might also want to look at the model score. So basically, this is the R² value, right? And here we can just do model.score. And here we're going to just put in, again, our X data and our Y. And this is going to tell us that basically we can capture 98% of the variance in the data with this linear model. And so this is just kind of a quick overview of using linear regression. This is single input, single output type regression. In the next video, I'll do multiple inputs to a single output. It's pretty much straightforward. And then as you're going to see, once we kind of get the basic mechanics working, we can start using different kind of machine learning models. We don't have to use just linear regression. There's much more powerful tools. We can also add features to our linear regression, like fitting, AX plus BX squared plus C, and that'll do in the next video. Anyway, if you have questions, please post them to the comment section or put them on Piazza. Thank you.